Welcome back to our channel. Today, we're going to dive into the fascinating world of everyday objects and uncover the surprising science behind them. From simple household items to things we encounter on a daily basis, prepare to be amazed by the hidden scientific principles at work. Let's get started. Why do ice cubes turn cloudy? Have you ever noticed that ice cubes in your freezer often appear cloudy? Well, the reason behind this phenomenon is quite intriguing. It all comes down to the impurities present in water. When water freezes, it forms ice crystals, but the impurities get trapped within these crystals, causing the cloudy appearance. The clearer the water, the clearer the ice cubes will be. The popping science of popcorn. Have you ever wondered why popcorn pops when heated? It's all about the water inside the kernel. Each popcorn kernel contains a small amount of moisture trapped within. When the kernel is heated, the water inside turns into steam. As the steam builds up pressure, it eventually causes the kernel to explode, turning it into the fluffy popcorn we love to munch on. The electrifying mystery of static electricity. We've all experienced those unexpected static electricity shocks, especially during the winter months. But have you ever wondered how they occur? Well, static electricity is created by the transfer of electrons between two objects. When objects rub against each other, one object gains or loses electrons, resulting in an imbalance of charges. When we touch a conductor, such as a doorknob, the excess charge discharges, creating that familiar shocking sensation. The science behind mirrors, those reflective wonders we encounter daily, hold a fascinating science waiting to be unraveled. They go beyond simple reflections, embodying the captivating principles of optics, light, and perception. When light waves strike a mirror, they obey the law of reflection, bouncing off at an angle equal to the angle of incidence. This fundamental principle allows mirrors to create accurate reflections of the objects in front of them. The quality of a mirror's reflection depends on the smoothness of its surface. Through careful polishing and coating, imperfections are minimized, enabling smoother surfaces that reflect light more efficiently, resulting in clearer and more accurate reflections. The choice of reflective material plays a crucial role in mirror performance. Silver is known for its exceptional reflectivity across various wavelengths, but it comes at a higher cost and is prone to tarnishing. Aluminum mirrors, on the other hand, offer good reflectivity and durability at a more affordable price. One intriguing aspect of mirrors is their ability to horizontally flip images. This phenomenon, known as lateral inversion, means that the left side appears on the right and vice versa. It is a consequence of the way light rays bounce off the mirror and are reflected back to our eyes. Mirrors find widespread applications in our lives. They are indispensable for personal grooming, providing accurate reflections of ourselves. In addition, mirrors play crucial roles in optical devices such as telescopes and microscopes, as well as photography, where they direct and focus light. They are also utilized in architecture and interior design to create an illusion of space and enhance natural light. Segment 5, the weighty mystery of balloons. Floating balloons have a captivating ability to float in the air, seemingly defying the force of gravity. The secret lies in the fascinating science of buoyancy, which involves the interplay of gases and densities. When a balloon is filled with a gas that is lighter than the surrounding air, such as helium, it becomes buoyant. Buoyancy is a result of the upward force exerted on an object immersed in a fluid, opposing the downward force of gravity. This force is governed by Archimedes' principle, which states that the buoyant force on an object is equal to the weight of the fluid it displaces. In the case of a balloon, as it fills with lighter-than-air gas, it displaces an amount of air equal to its own volume. This creates an upward buoyant force that exceeds the weight of the balloon and the gas it contains. Consequently, the balloon experiences a net upward force, causing it to rise and float in the air. The key factor enabling balloons to float is the difference in densities between the gas inside the balloon and the surrounding air. Helium, the gas commonly used to fill balloons, has a lower density than air, making it an ideal choice for achieving buoyancy. The density of a gas is determined by the mass of its particles and the volume they occupy. Because helium atoms are lighter and occupy more space compared to the nitrogen and oxygen molecules. Conclusion, and there you have it, the surprising science behind everyday objects. From the cloudy ice cubes to the popping popcorn and the electrifying static shocks, these everyday phenomena are rooted in scientific principles that make our world more fascinating. We hope you enjoyed this exploration of the science behind everyday objects. Stay curious, and until next time, keep exploring the wonders around you. Thank you for watching. If you found this video interesting, don't forget to give it a thumbs up and subscribe to our channel for more mind-blowing content.